Algebra 1, Factorizing Expressions 1. So this slide is about factorizing expressions, number 1. When factorizing expressions, you are basically placing terms outside, then inside brackets by dividing coefficients and subtracting powers. So basically, factorizing expressions can be summarized as placing terms outside as coefficients outside the brackets, so that will be a coefficient, then placing terms inside of the brackets. And to place the terms inside the brackets, you have to divide the coefficients and you have to subtract the powers. Divide coefficients and subtract the powers of the same letters. Now, whatever you put outside the bracket, which is called the coefficient will be outside of the bracket. That is the bracket on the left side. Must interact with all the terms to go inside the brackets. Interact meaning dividing of coefficients and subtracting powers. To do this, you place outside an open bracket the highest common factor of the numerical coefficients and the letters with the lowest powers or exponents. That's what you place outside of an open bracket, and that will be a coefficient by itself because it will be multiplied. To obtain the terms inside the brackets, you divide each one of the terms by whatever you placed outside the bracket. So whatever you place outside the open bracket, you have to use that to divide each of the terms so that you can know what to get to put inside of the brackets. So when you're dividing, you divide the coefficient, that's the numbers. Remember, a negative divided by a negative is a positive, and a negative divided by a positive is a negative. Then you subtract the powers of the identical letters. You do not need to write powers of 1. You cancel out letters with powers of 0. So let's go over that again. To obtain the terms inside of the brackets, whatever you put outside of the open bracket, you divide each one by that. Divide each one by what you placed outside the open bracket. And when you're dividing, you divide the coefficient, that's the numbers, and you have to remember that a negative divided by a positive is equals to a negative, and a negative divided by a negative is equals to a positive. And then you subtract the powers of the identical letters. Take note, you do not need to write powers of 1. So if you have power of 1, you don't have to write the number 1. And powers of 0, the letter cancel out. Then you close the bracket. Example, factorize the following expressions. So you have 4x cubed y to the 4 plus, so 4x cubed y to the 4 is a term, plus 12x squared y squared, that's another term. So that expression has 2 terms. So you look at the coefficients, they are 4 and 12. You look for the highest common factor, what can go into 4 and can also go into 12, the highest number, and that will be 4. So you write down 4. Then you look at the letters x. You look at the powers, x to the 3 and x to the 2. So x to the 2 is smaller than x to the 3, so you place that by the 4. You place the letter with the smaller or the smallest power. Then you move on to the y. Y to the 4, y to the 6, y to the 4 is smaller, so you place that outside of the open bracket. So you have 4x squared y to the 4 outside of the bracket. So that 4x squared y to the 4, as we will explain now, is a coefficient by itself. Now you're going to use that to divide each of the odd terms for you to know what's coming into the bracket. So the 4x cubed y to the 4 have to divide by 4x squared y to the 4. And the 12x squared y to the 6 also have to divide by the 4x squared y to the 4. So you see 4x squared y to the 4 is placed outside of the bracket, and it is also the denominator. It has to divide into both the terms, so that as you can see in the equal sign, you can know what comes into the bracket. You close the bracket and you have 4 divided by 4 is 1. You don't have to write 1. 3 subtract 2 is 1. 4 subtract 4 is 0. Plus 12 divided by 4 is 3. 2 subtract 2 is 0. So you have x to the 0. 6 subtract 4 is 2. You have y to the 2, and this simplifies to 4x squared y to the 4, open bracket, x, because you don't have to write to the 1, and any letter raised to the 0 cancels out. So you have x plus 3y squared. Second example, you have 6p to the 5 q to the 8 multiplied by 5p squared y to the 4p squared q to the cube minus 4 close bracket. So this now is the opposite of factorization. So this example was placed there to show that expansion is opposite to factorization. So if you have to start on the right hand side, then you're supposed to get the same thing as 6p to the 5 q8 open bracket 5p squared q cubed minus 4. So the exercise now for this example B is to start with 30p to the 7 q to the 11 minus 24p to the 5 q to the 8 and see if you get back 6p to the 5 q to the 8 open bracket 5p squared q cubed minus 4 close bracket, because 6 to the p q to the 8 open bracket 5p squared q cubed minus 4 close bracket is a factorized term already. So the opposite of factorization is expansion. The opposite of expansion is factorization. So let's move on to the three expressions that you have there for exercises. Factorize 12x to the 7y to the 5 plus 18x squared y to the cube. You have 8p squared q to the 5 minus 14p q. And you have 8p squared q to the 5 minus 14pq plus 16pq to the 3. So you just remember, check out the coefficients, look for the highest common factor, then systematically look at each letter and the one with the lowest power. You put it outside, you open a bracket, you divide coefficients, subtract powers, close bracket, and then you have your factorization. Factorization implies that your final answer must have brackets. So remember that when you are factorizing, your final answer must have brackets. And outside of the bracket will be a coefficient.